Okay, so if we're asked to factorize the following, so we said we're going to use the MAM method. So the MAM method tells me or asks me to find two values. So I'm looking for A times B equal 12 and A plus B equals 7. So straight away, to get a 7, I need an odd and an even number. So that can just be 4 times 3. And that is just 4 plus 3. So those two numbers work fine for me. So the trick here, because here we've got a number in front of x squared, we are going to rearrange 7x using the two numbers that we found. So we rewrite this as 2x squared. So that's the trick, basically. Plus 4x plus 3x plus 6. Okay. And now we're going to factorize 2x squared plus 4x, and we're going to factorize 3x plus 6. So you can get 2x out times x plus 2, because 2x times x is 2x squared, 2x times 2 is 4x. And here I can factorize using 3 times x plus 2, which is good for me now because I've got x plus 2 times 2x and x plus 2 times 3. So I can just factorize using x plus 2 as my common factor times 2x plus 3. So this is how I would factorize this. And I can quickly check 2x squared plus 3x plus 4x, that's 7x, 2 times 3, 6. So I know if this was 3 marks, 1, 2, 3, I would get them because I've quickly checked it. Okay, so the only difficulty is once you found your two numbers is replace 7x to help you factorize further. Now, the second question I've got here is the TV is reduced by 20%. So because I like algebra so much, I'm looking for a value. The original price, I'm going to call it x. So I'm going to say original price is x. So that means if I had my original price and I reduced it, that means I take away 20% of it. My answer would be £200. So 20% of just mean time, and 20% is just 0.2. So this is where people would tell you, so I've got x minus 0.2x equal to 100. X is just 1x. 1x take away 0.2 is 0.8x. This is where people would tell you 80% of x is 200. But if you ask where is that 80% coming from, it's just 100% take away 20%, which is your 80%. Or you can just write it as 0.8. And now x, which is your original value, is just 200 divided by 0.8. Or if you don't like decimals, it's just, you can time by 10 the bottom and 10 by 10 the top. You get 2000 divided by 8, which is 1000 divided by 4, which is 500 divided by 2. And what's 500 divided by 2? £250. So that was my original price. So it's been reduced by a fifth, which is 20%. And the fifth is £50 to get my £200. Okay. And before I would go, I would quickly check that 250 minus 20% of 250, which is 50, is equal to 200. And just to give your answer correctly, it's money. Okay, so that's how you use algebra to solve any problem. Now solving these, I've got two factors, 2x minus 1 times x minus 1 is 0. Either this one or this one would equal to 0 give me the answer. So 2x minus 1 equals 0, or x minus 1 equals 0. So you add 1 on each side to get rid of that 1. Then that means 2x equal 1. And then you divide by 2, which gives you x equal a half for this one. And for this one, you just add 1 on each side, get rid of the 1, and that means x equal 1. So those are my two answers. And when x equal 1, this is equal to 0. And when x is a half, 2 times a half is 1. 1 minus 1. This would make it 0. Okay, guys. So that was your starter question to warm you up. Now, learning intention for today. We've got to investigate 3 different graphs: the sine, the cosine, and the tangent. So where do they come from? What do they mean? We're going to try and explain that. You'll be successful if you can identify key points for those graphs. And the key points are going to be, we're going to try and learn how to find the amplitude, how to find the periods, and where the roots are. Remember the roots? When we had a parabola is where my graph cut the x-axis. It's not the y-intercept, it's the other one, the x-intercept. Okay, so how do we create a sine graph? So let me see if that works. I'm going to pause the recording for a few seconds, and I'm going to bring, that's not what I wanted to do. So I'm going to share with you guys. So if I can pause. So we have a circle, which is what we call the unity circle, because you've got its radius is equal to 1. So with the radius equal to 1, we've got what we call angles. And as you can see, you still get that triangle here. That's why it's part of the trigonometry. So what we're going to do is we're going to try and show how the sine graph is built. So if I click on this, show line graph, and I start moving my points on the circle, you would see something happening with the sine graph, right? So you can see the sine graph being built. So I've moved the angle down to 0. And when I move to 0, I've got my sine here is equal to 0. When I start increasing my angle, you can see the sine just keeps increasing. The sine graph itself keeps increasing. And when I reach 90 degree, my graph is at its peak here. We reach the value of 1. Remember, this was the unity circle. So if I keep going, through, I'm at 180 degree now, and I keep just going. So what you've seen now is us building what we call a sine wave, just using a circle and different angles. So that's where the sine wave is coming from.
equals to certain points of.
Yeah, so you've got, for each different angles, you've got a value of what we call the sine bar. So basically here on y, for every y here, we go from 0 to 1 and from 0 to -1. So imagine this is +1, this is -1, and that's how you would build your sine graph. Okay, so I'll show you again. Can I clear it? Yeah, so you would need to just re-enter. So this point here is a half. So we've got the point here, 0.5. So what I said was the y-axis is the value of your sine. So sine 30 degree is 0.5, because this is where 0.5 is. Sine 0 degree is 0. Sine 60 degree is another value, but if you type it on your calculator, it'd be like √3/2. And sine 90 is 1. So we go from 0 to 1 and from 1 back to 0 if we keep increasing the angle. And when we go into from 180 to 360, this time my graph goes into its negative value and back at 360. And if I was to keep going after 360, you would just repeat the same graph here. Okay, so that's what the sine graph looks like. Now let's have a look at the cosine graph. So when you come to cosine graph, can you still see my screen?
Mm-hmm.
Okay, so we use the y-axis to plot the value of sine. We're going to use the x-axis to plot anything to do with cosine. Okay, so that means to get half, I need to be at 60 degree here. So if I was to go cosine of 60, you will get 0.5. Whereas when it was sine of 30, we got 0.5. And when you add 60 and 30, you get what we call the right angle. And you've noticed now 60 plus 30 is a right angle. And we called two angles that you add. Remember when we look at angles and they give you 90, we call those two angles complementary angles. So cosine just means complementary of sine. Okay, so if I'm at 0 degree, I'm at its maximum, 1. Whereas if I'm at 90 degree, the cosine becomes 0. It's a bit the opposite of sine. When we had 0, we had sine, which was 0. But when we went to 90, we had our sine, which was at its maximum point. So they just complement. And then you keep going down. This time in the second quadrant here, I'm negative to -1. And then you keep going back up. At 270, we pass by 0 up to 360. So basically the cosine graph, you can keep going that way, or before that, you'll see that it's what we call periodical. So you just keep repeating the same over and over. Okay, so those are the sine and the cosine. If we were to plot the tan graph, tangent, so it's another graph that you may get asked to identify in trig. So the tan graph is a bit more complicated. So let's see with different values. So it starts at 0 when when tan equals 0, and it goes up. And then when you pass 90 degree, you could see it coming back up again from the bottom, and it passes by 180. And then you keep going. It's going to take the same shape of what we saw between 0 and 90. And then it's going to come back up again from the bottom. So basically what we call these lines is, if I had a smaller scale, this would just keep going up and never touches this line. And then once you pass 90, the tan would start to be close to what these are called asymptotes, because it's your graph just being close to them without touching them, and then you just keep going up. So to me, when I look at this, I've got something repeating itself every 180 degree, and you'll learn that the tan itself has got a period of 180 degree because it repeats itself. So that point here is the same as this point here. Okay, so that was a brief introduction on the three graphs using what we call the unity circle to show you what they look like. Okay, so I'm going to stop sharing this just now. We're going to pause. So we looked at it. We went from 0 to 1, and it went back down again at 180 degree, and then keep going down to -1 and up to 360, all using the unity circle. So the thing that we need to remember from a sine signal, you've only got to sketch it, but in order to sketch it, you've got to know a few key features. So because the sine signal repeats itself every 360 degree, you just say period. So periodically is something that keep repeating itself. The period for the sine signal on its own is 360 degree. The maximum value is what they call the amplitude. So it goes from 0 to 1. And the minimum value here is -1. You can see that we never go below -1. So that's the minimum value. It's a bit like I've got a maximum turning point and a minimum turning point if you use the parabola. So key features, apart from period, max, and min, we've got the roots. We've got a roots at 0, 0, another roots at 180 degree, and the third root where we cut the x-axis at 360. So the sine signal has got three roots, 0, 180, and 360. The max value 1 occur when the angle is 90, and the minimum when the angle is 270. Okay, so those are your key features. We did the same looking at the cosine, but this time, okay, the period is the same with 360 for the key features. The maximum value was 1, happen when my angle is at 0 or when my angle is at 360. And the minimum value is at -1. We've got only two roots this time between 0 and 360. So the first root is at 90, and the second root is at 270. Max value occur when x equals 0 or when x equals 360, and the min value is when x equals 180. So looking at the tan signal, that's what it would look like. This time my period is 180 because that 0 here occur again here at 0. So we've got that same shape here and there. So period 180. So in Nat5, you don't get asked to draw a tan. So when you're asked to sketch, it's 99% of the cases on past paper that I've looked at, it's always sketch the sine or the cosine. You don't get asked to, but it's good to know what it looks like. So key features, 0 at 0 and 180, and 360 if you want. Okay, so that's why we don't spend too much time with the sketch of it. So those are your three graphs. Okay, so we've looked at sine x and cosine x. The next thing we will look at, and I'm going to let you have a 10 minutes break, is what we call when you've got a factor in front of when you got a factor in front of sine and when you got a factor in front of cosine, what does your graph looks like when you put a value in front instead of, remember the sine x by default a is 1 because 1 sine x is just sine x, and that's why you use the unity. So we're going to look at what it looks like when a get increased or decreased. Okay, so I'm going to let you take 10 minutes break, get a tea or a coffee, and then we can be back at 7. I'm going to pause the recording. Okay, if I can. Okay, so again, this time, once we've identified our graph, we'll make sure that we know the key points for those different trig graphs. So the key feature we had is just to remind us. Let's say if I ask you to sketch y equals sine x, this is what it would look like. It goes from 0 to 1 at 90 degree and pass through 180 degree at 0 again, -1 up to 360. So that would be y equals sine x. Now, if I ask you to change, remember we've got an invisible 1 here. Change that invisible 1, which made me have an amplitude of 1, and change it with a 2. What do you think the amplitude this time is going to be?
2.
2, yeah. So basically, the only thing that gets changed here is the amplitude. We've not touched anything within the angles, so the only changing factor here is that number, and your graph just got a bit bigger. So the amplitude went from 1 to 2, but it goes to 2. The maximum is the same maximum we had when we had just sine x, which is at 90 degree. Okay, so basically we just made it a bit wider. So what would happen if I try 3 sine x?
Got 3.
Yeah, the green graph, we just start at the same point, but it just goes up to 3. So if you're asked to sketch 3 sine x, you remember what sine x looks like, but you just make it bigger by changing, by going from, instead of 1, right up to 3. Okay, so that was if a is bigger than 1. What would happen if I make a less than 1? So remember, if it was bigger than 1, we were increasing. If it's 0.5, you just mark your 0.5 here. So instead of growing up, it would just go 0.5 here. Okay, so basically you go up to 0.5. Okay, so instead of stretching, this time we squeezed it. So what effect does the number at the front have? If we have minus sine x, this time it's a -1. So the amplitude, instead of being +1, the amplitude will just go -1. So we will start at the same point, but we will go through -1 first, and then going back up. Okay, so we've just flipped the sine x into a minus sine x. It's like a mirror across the x-axis. Okay, so now what we need to remember is for a greater than 1, our graph stretches in the y-axis. It's a bit like growing up. For a between 0 and 1, we just compress it, so it becomes less than 1, the amplitude. But when we've got a negative, we just flips the graph. So you think about how the positive graph would look like, and you flip it in the x-axis. So 3 things to remember. So this was y equals sine. So if I draw a graph like this and I ask you, what would you call this graph?
5 sin x.
Yeah, so it's a sine x with an amplitude of 5, 360, 180, 360 the period. So you would just say this is y equal 5 sine x. The green one would be y equal 4 sine x, yeah?
0.5.
So remember this is 2 and this is 1. So that would be sine x. And this one,
-6.
-6 sine x. So you need to mention that it's a sine, a sinusoidal, yeah, sine x, -6 sine x. So it's just the 6 that has been flipped across. So there you go, your answers are there, 5 sine x, 4 sine x itself, and then -6 sine x. Okay, so I hope it's a bit like having a visual memorization, but at the same time, it's good to know where it's coming from. So we're gonna try and do something similar with the cosine graphs this time. So the thing to remember for sine is it starts at 0, 0. Basically, it's the graph itself starts and then grows up. So go up and then come down, or would come down if it's a negative one and goes back up. Whereas as opposed to a cosine, if you're given a cosine, you will see it starts and start to come down first. Okay, that's how you could tell the difference. It would just goes down first, whereas a sine will always go up the way or go down the way if you've got a negative in front. So these are the key features we looked at about 20 minutes ago. The max, the mean, the zeros. So now let's try and plot y equal cosine x. So that's the standard one. We start at 1, go through 90. It's a bit like the sine, but it's happening. It's as if sine is shifted by 90 degree, if you see what I mean.
Yeah.
Compared to sin, yeah.
Yeah. That's why it's the complement of it. So if I was to do 2 cos x, so instead of being at 1, we start at 2, but we pass through those same points. So very similar to what we were doing. So this is 2 cos x. This would be 3 cos x. So you start at 3.
3, 9, 10.
And then going up and down. So again, with a positive value of a greater than 1, you stretch your graph. Whereas if you get a between 0 and a 1, you'll compress it. So it goes to 0.5 cos x. And if you've got a negative, same thing as what you were doing for the sine. If you were to get y equal negative cos x, instead of starting at 1, this time it's going to start at -1 and it's going to go up. Okay, it's just going to be flipped. So that's your negative cos x, basically. You take the cos and then you flip it. Okay. So what would that be?
2 cos x.
2 cos x, yeah. This one.
4 cos x.
4 cosine x, yeah, 4 cos x.
6 cos x.
6 cos x, yeah. So now you get the hang of it. And this one,
X.
cos x itself.
Cos X.
because we don't pronounce the one. Yeah,
Yeah.
cos x. Same as when we had x. This time, negative
Because-
cos x. Yeah, so basically it's cos x that's been flipped. So it's negative cos x or minus cos x. So there you go. So for your first homework, it's going to be very much what we've just done there. Identify some of them or draw a few. We'll have a look at a couple. So just gives you an idea. If you want to take page 254. So that's probably past now the midpoint of your book, because the whole book is 382. So you can see now 254, we've passed halfway the book. Exercise 23A, question 1 and question 2. Again, those are like the star exercises. And if you want to do more, guys, feel free. So what I've put here for you is something that is quite interesting. If you were asked, for example, during your homework, draw, I don't know, 3 cos x, you can try and draw it, but I'm going to give you as well this important website. So it's a free website. And if you type www.desmos.com/calculator, it just gives you a graph that you just need to type on the left-hand side. So I've typed there y equals sine x, and you could see that I've got y equals sine x being drawn for me. You can change if you want the axis. So here I had right up to 6, but you can change that. Okay, so let me show you. I've used that because what I did was once I've put it up, I copied the grid so that we can draw now y equal, sketch the graph. So your first exercise would be to sketch y equal 5 sine x, y equals 3/4 of cos x, negative 4 sine x. So you're going to pick one and we're going to try and draw it. So pick any of those and then I'll go through it with you. And that means you can do the other ones. So A, B, C, D, E, F, which one do you want to try and do?
Why don't I try B?
B. So, okay, 3/4. So let's see. I'm going to pick a better color than the white. I think at the moment it's defaulted to white. So it's got red. Yeah, so let's pick black so that we can see it. So if I'm asked to draw 3/4 of x, which is B there, so we're going to do B. So that means instead of reaching 1, first of all, it's a cos signal. So the cos x would start at 1, okay? And we'd go down at 90 and going back down right up to 180 before coming back up to 170. Okay, so what you could do is you could draw cos x because that's the one that you are more used to. So you would go, this is cos x, you would go to 90, then you would go down right up to 180 here. Then you would go back up to 270 and then at 360. So that would be cos x. Okay?
Yeah.
Because that's the one that we've looked at, 1 cos x. 3/4, so I've got 1/4, 2/4, 3/4. So I'm going to change the color. This time I'm going to make it in red. So 3/4 means my amplitude is going to be 3/4 here. But I'm going to pass through these same points because we've compressed. So 3/4 would be here and 3/4 would finish here. But the roots are going to be exactly the same. So 3/4 of cos x would just be that one there, going there, passing through 90, passing through my red one there, passing through 270, and finishing at 3/4. So that's your B here.
Yeah.
And if it was a half, then you go a half of 1.
In question 2, Adrian, sorry, in the homework, it just says state the equations of each of the following. So you would simply just say whether it was 2 cos x or 4
Yeah.
sine. So it's just stating whatever.
Correct. For the next exercise, you will be given a graph and you just need to write if it's 5 sine x, or whereas in this one, we've been asked to sketch it. Okay.
In a typical exam question, would it be like sketch the graph, or would it be more doing the?
Yeah, it could be either. You can sometimes you get sketch it, or they can give you one and say, can you state what function is this one?
Okay.
Okay.
And I presume you would get the graph
Paper,
started
yeah. So you
like
would get
that?
some graph paper. So basically, you might not get graph paper. So what you need to do is you need to get your ruler and decide, use some good space in between. So as long as you know you go from 0 to 360
Yep.
and 180. So those are the main one I would usually put is 90, 180, 270, and 360. Those are the 4 that you would see people putting in.
Yep.
If it's a basic sine or cosine. Yeah, to me, because I've used Desmos there, it just plot me all of them. I just said go from 0 to 390 in step of 30, and then it plots it for you. Okay, so that's a good thing about Desmos. But this is what you would do if you were asked to plot something, right? So that's enough. You don't need to even put, you see those blue lines here? You don't need to add them. You only need to put X and Y and put the numbers there.
Yep.
Okay, so for second exercise, I've got here A, B, C, and D. You pick one, and we're going to try and see if we can write down the equation for that.
I picked the last one, so there you go, John.
First one.
First one. So we're going to try A. So when I look at A here, remember, in my head, I've got what the sign looks like. So I know it starts at 0. This one doesn't start at 0. So I know this is something, it's got cosine in it. It's got 360 degree. So I know it's cosine x. So now I need to deal with my amplitude, right? And we said that the normal cosine x, if it's 1 cosine, start at 1, whereas here start at 4. You just write 4 cos x. So state the equation. You can just say y equal 4 cos x. That's how easy it is. Okay.
Yep.
So here, yeah, let's do this one, for example. So if I'm given something like this, first thing I'm looking at is, usually I look at the shape. The shape is telling me period of 360, this is a sine x, right? So the first thing I put sine x in degree. My amplitude is 0.25. They expect you can put 0.25, but better mathematician would put it as a fraction. And that's you, y equal a quarter of sine x. So it's got the sine wave and an amplitude of 0.25. You would get the same mark if you had written 0.25 sine x. Yeah. Okay.
Yep.
So there probably be more than just those two. Okay, so we've looked at when you put, we're gonna pass those. So the first thing we looked at is changing the amplitude. So now let's see what happened if in my graph, instead of just having the amplitude change, but we're going to change not only the amplitude, but we're going to affect in somehow what we call the period. Okay, so far we've only looked at making it bigger or smaller in terms of amplitude wise. Now, can we stretch it, change the 360 into another number? Let's see what it looks like. So this will affect what we call the period. A has got an effect on the amplitude. B changes the period. So let's have a look what it look like if I've got an A sine bx. So I'm not going to change A just now. Let's have a look sine bx. We're going to investigate just sine bx. We know the sine x has a period of 360 because it's periodic. It repeats itself over and over every 360. So when we had sine x started at 0, went up to 1, went down at 180, went down to -1, and went back at 360. So this is what we looked at, okay? So what happened if I change now B? If I put 2x, so I'm going to tell you what the 2 means. The easiest way to remember this is to say, if you've got sine 2x, when you had sine 1x, remember that invisible one? You had one wave within 360.
Yep.
Sine 2x means I'm going to put 2 waves within 360. So let's have a look what it looks like when I put 2 waves. Have you noticed what happened? The amplitude didn't change. Yeah? The amplitude is the same, but this time I've managed to fit 2 of them within 360. And because you've got 2 of them within 360, my period has changed because now it repeats itself every 180. Yeah, so that's what the period is. Have you noticed the period now is half? So basically, instead of 360, the period became 360 divided by 2 because I fit it. Yeah, so it's 180. So basically that number, if you're asked what is the period of this, you do 360 divided by 2. And if you're asked to draw it from 0 to 360, just means you need to put 2 of them within 360.
Yep.
Okay, so let's have a look at a different one. Sine 4x this time. So this time I've been asked to put 4 of those sine waves within 360. So if you look at it, you've got 4 intervals here. So that means I'm going to have to fit one here, another one there, a third one, and a fourth one. And my period is going to be now 90 degree because you can look at it. What I've done is I've changed the period. And in real term, what that means is we've changed the frequency of the signal. Okay, so if you're a musician, for example, someone working with sound, or even listening to different keys in a guitar or on the piano, your signal frequency changes as you hear different notes. And that's what it is basically. You change the period of your signal. And what signal does is just compressing air and hit your eardrum. And the quicker those comes together, the different sound your brain associate them to. So since you were born, you've learned different sounds based on how quickly it was vibrating on your eardrum. And it's all using mathematics. We can put a mathematical expression for all those signals. Okay? So that's all it is. You change the frequency, you hear a different sound note. And to represent a different frequency is changing the period, okay, which is what we're doing here. So if we're asked to draw this time sine of, remember we were drawing 4 within 360. Now, because we've changed to less than 1, we need to draw half of a cycle within 360. Okay, so what would that look like? It would look like this, because that means my period now is twice 360.
Yeah.
720. But as you've noticed, the amplitude never changed. It's just how more of those we have within 360 that's changed. So let's summarize all that. What effect the numbers got. So we've got two, we had 2, we had 4, we had a half. So whenever you've got, so A we decided was to stretch in the y-axis direction, whereas the B itself, how many times it repeats itself within 360. That's what it does. Okay, so that summarizes well how you would interpret or how you would sketch the graph itself. Okay, so now let's get some examples. So this is y equal cos x. So we've done sine. If I've got y equal cos 2x, so I need to put 2 of these signals within 360. So that's what it would look like. Have you noticed now it looks like more of a sine signal from there to there, but that's because we've got the first one here and then the second one here. Cos 3x, you would need to fit 3 of those within 360. 1, 2, 3. So basically, you may look at this and say, oh, that looks like a sine, but no, you look at the start, how it starts, and you know this is cosine. You've got 1, 2, and the third one. So it could be a bit confusing, but just look how you start, or if you want, how you finish. Now, let's try this one. I've got 1, 2. So that's the green, cos 2x, cos 3x. And the same thing that happened with the sine, we stretch, we change the amplitude by changing the number in front, and we change the period with the b. Okay, so if I looked at a tan, which we're not going to do because you don't get asked to sketch a tan with a and b, it's exactly the same thing, but instead of 360, the period for tan was 180. So let's have a look here. What do we have? So we've got the red one, and we've got 2 of them within 360, and that looks like a sine signal. And does it go? So basically, you've got 2 sine 2x, sorry, and the amplitude, yeah, just take it, but it's 0.5. Should have gone a wee bit down a bit. To me, it's closer to 1 than 2, but so 0.5 half sine 2x. So we're going to combine both a and b this time. So we've got 2 periods of the sine signal. So let's try another one. So is that a sine or a cosine?
Sine.
Yep. So sine. How many have I got?
Yeah.
1, 2, 3, 4. So I've got 4 of them. So I know this is sine 4x. And what's the amplitude?
2.
2. So there you go. So if you were given this and ask, what is this? You would just say this is 2 sine 4x. Can you see the full screen? Can you see the 4x okay? Or does it have something in front of it?
No, it's fine.
Okay. So the next one. So this time, remember, I don't have 1 period, but I've got half a period. So if I was to draw this, this would be something like a sine upside down, but sine half of x, but minus 3 sine half of x. Yeah?
Yeah.
Yep.
Yeah.
Okay. So it's been flipped. This one was the red, 0.2 sine 2x. We've done that one. 2 sine 4x and minus 3 sine half of x. Now with the cosine, so write down the equation. So try to write it down. Take your time. see if you would get this one okay. Okay, so the first thing you would ask yourself, is that a cosine or a sine?
Sine.
Sorry?
Cosine.
Cosine, yeah. Yeah, so start up there.
The amplitude's
Cosine. And how many have I got?
2.
2. So it's a cosine 2x with an amplitude of 1.5. Yeah, 1.5. So you can write 1.5 cos 2x for this one. You'll get the mark. If you write 3/2, which is a fraction way of writing 1.5, you get the same mark as well. Okay?
Yep.
Or in mixed fraction, you can see even writing with 1.5 next to it. What about this one?
-2 cos.
2 cos 2.
So let's see, I've got 1 and 2, yeah? -2 cos 2x, because we've got 2 periods. I'm getting the hang of it. Let's try another one.
So you could do it 0.5.
Yeah, 0.5 for the amplitude.
Was 1,
So I've got 1, 2, 3,
4.
Yeah. You just look at how many times it repeats itself. So 0.5 cos 4x, yeah. So we've looked at all 3 of them combined. And now for your wee homework part, page 255 and 258, 23b and 23c. And this time we're going to be looking at amplitude and period changing. Again, it's practice. Once you've done quite a few, you'll be able to spot them.
Yeah.
As long as you've got a technique, you just follow it. It's usually okay.
Thank you.
So let's try, we're gonna do again. So I've used the graph from Desmos to just print me the background. So let me see what's the next one. So we've got cos 3x, cos 4x, sine 5x. And you've got some that are a bit more complicated, but you pick which one you want us to try.
E or E look quite nasty.
E or F?
Yeah, yes. Well, there's nothing in front of those.
Okay.
Yeah,
All
try
right.
F.
Yeah, so we're gonna try, let's try and do F.
Aha.
So pen color red, yeah. So I'm gonna pick a black first and draw sine x first, because I like to draw the basic one. So for sine x, we said we start at 0. At 90, we get to 1. At 180, we cross back here because I know sine x is 360, the period. So it goes to 270 and 360. So if I was asked to draw sine x, this is how I would do it. 0 to 1 there, come down to 180, and then to 270, and back up to 360. That would be just my sine x, right? That's not what they've asked me to do. Now, we've been asked to do sine half of x. So because it's half, that means I need to put half of a cycle of sine here. If this is a full cycle, half of a cycle is just that top part. So that means my 0 is going to be here, but my 90 is going to move to 180, and then it's going to come down to 360 here. So basically, it's just drawing this, reaching there, and just keep going down, up you get to 360. And normally, because we're drawing from 0 to 360, I'll stop here, but that would just keep going if I were asked to do it from 0 to 720, for example. So that would be f, or sine of half of x. Okay. I've got half of a cycle within 360.
Yep.
So let's see what we've got here. So the next exercise is a bit easier because they've already drawn the graph for you. You just need to state what else. So we've got A, B, C, D, E, F. Yeah, A, B, C, D, E, F. We're going to pick one. You can pick whichever one you want.
E.
Yeah, E. So let's pick E, for example. So if I'm given E, so the first thing I'm going to look at is within 360, I've only got half of a cycle. But the half cycle here is at 180. So let's see what they say. So if I've got 180 here, remember the 360 would keep going, yeah?
Yep.
So you need to watch. So the amplitude here is -1. So that's a minus. Because I'm starting at 0, it's a sign. Yeah? Minus sign. And because this will go up to 360, this is just minus sine x. But you've only been given half of it. So you need to really watch that. You know, the first one is 360. So what I would say to my student usually is draw the first one, the 361 that you know, and then see what it looks like. And you'll be able to see that, oh, that's just minus flipped because if this was going to 360. So you need to really watch. The same here. If you think, oh, I've got 1, 2.
Have you not only got 1.5?
So yeah, you would say, oh, I've only got 1.5, but technically you've got 1.5 times 2, that's 3. You've got 3 within 360. 1.5 within 180, but 3 within 360.
Yeah.
So that would be your negative cos 3x. Oh, sorry, negative cos 3x because it's a cosine. Okay. So again, it's a bit of gymnastic and trying to get through them. The easiest one are when you go from 0 to 360. But if they've got 120, remember 120 to 360, you've got that 3 times. Okay. For this one, sketch those graphs, and they tell you to sketch it from 0 to 360. So let's have a look. We're going to let's sketch one in the middle, for example, D, right? So if I was to sketch D, first thing first, okay, so I've got 4x. I need to put 4 of these within 360, 4 of my sine x. So 360 divided by 4 is 90. So I need to put, so then that means I'm going to have to cut here. So that's going to be one of them. And because my amplitude is 2, I need to go up to 2. So if this is 30, 45, so I'm halfway there. And I'm going up to 2 here. So there's always that symmetry. 3 here, and I'm going to -2. So that's going to be my first one. But remember, I need to do 4 of these. So 1. Then you do the same,
Yeah.
just done. 2, 3, and 4. So 90. I add just that here. And 180. Going through here. And halfway between them two. So that would be my second one. So you just repeat the same thing. So it's quite repetitive. You go there, right up to there. And you would go there, right up to there. And halfway through, you would get to 2. Halfway through, you would get to -2. Again, here 2, and here -2. And then that would be you. You just go up and down for your sign. And then up and down again to do your fourth one. Okay, and that would be 2 y equal 2 sine 4x drawn between 0 and 360 degree. Okay, and if you've got a negative, you just flip it. So 23C, you've got quite a few when we come back. This time we've been asked to state the equation of each of these. So I've got A, B, C, D. So let's try this one. We can do F if you want, but 360, that's a half. So 5, this one would be 5 sine half of x. So that's easy. But this is a bit more tricky. So let's try and do this one. So straight away, I can see I've got cos, and I've got 1, 2, 3 of them within 120. So if I've got 3 in 120, I'm going to have 3 times 3, 9 of them within 360, yeah? Remember, I've got 1, 2, 3 within 120. That means it's 9 within 360. And because it's a cos, I'm going to have a cos 9x. I've got 9 period within 360. And my amplitude is just 0.5 or a half. So that's important to see the scale that you have and decide how many. So if I had only 1.5, then I would time 3 times 1.5 to give me that number there. Okay, and if they ask me, what is the period for this? The period would be, so if you're asked, what is the period for your signal here? I can see that the period is from 0 to that value there. But what is the value there? It's just 360 divided by that number there. Divide by 9. And what's 360 divided by 9? 40 degree, yeah. So your period would be 40. So every 40, this just keeps repeating itself. So that would be 80. And then 120. Okay?
Yep.
Yep.
So we can do this if you want.
Yeah.
Yeah.
You want to bash on, yeah? Instead of looking at starter questions. Yeah, so we've looked at amplitude. We've looked at period. Here the period is just 1. So this is easier. Now what we're going to do is we're going to add a value to A sine x. And we're going to see what adding a value to A sine x will do to the graph, okay? So it's not complicated. Let's have a look. So A sine x plus B, A cos x plus B, we're going to look at those graphs and see what it does. So if I'm asked to write the equation of this graph, what I can see is the graph, instead of this time starting at 0, the graph starts at 0.5. But I can tell that it's got a sine wave on it, but it's always above that line. So it's a bit like someone went and moved the whole graph that I know goes to positive and negative from 0 up to 0.5 in the positive side. That just means I've got my sine x signal, we've added 0.5 to it. But what is the amplitude? The amplitude is just that part here. Remember when we were doing sine x? The amplitude was from where it was cutting 0. And what is this? If that is just the same as this, so this is just a 0.5 in amplitude. So you would just say that this is 0.5 sine. So how many have I got within 360?
Halfway.
So
Yep.
2 of them. And then it's been shifted up by 0.5.
Yeah.
So
Sneaky.
amplitude is this one. Shifted up is this one. And I've got 2 of them within 360 is this number here. So maybe I should have made these numbers with different colors. So that corresponds to that. That corresponds to the shift in here. And the period is just how many times. Okay, yeah, it's a bit of a sneaky one, but you could be asked to state the equation of one of these. So let's try another one. So I'm going to change my pen to green this time. So again, instead of starting at 0, it's been shifted down, yeah? So whenever you're going to see this shift, that means you've got your sine, but because it's been shifted down, it's going to have a -1 after your sine signal. How many period have you got? 1, 2, 3, 4. So I've got some sort of a sine 4x here. And the amplitude, remember, it's between the middle of it right up to the top there. So I've got from -1 to 0, that's 1, and another 1. So 1 plus 1, 2. So that's my amplitude there. 2 sine 4x. If that was 2 sine 4x, be there, but it's been dropped by 1 minus 1. Okay. So let's see if that makes sense. 2 sine 4x minus 1. And you could see where that -1 is the shift on the whole graph.
Who's not where you started essentially?
Yeah, so if you don't start at 0, then that means you've either gone up or you've gone down. And if you've gone up, you've added. If you've gone down, you've taken away from your graph.
The period delays, and then obviously what you've gone down by. It's just because I was confused with the starting.
Yeah. So for the period, yeah, I'm not looking at from there to there. I'm looking at the overall shape and how many times does it repeat itself, basically.
4 times.
Yeah. Okay. So let's try another one. Oh, we've done this one and we've done this one. And that's how you would. Okay, so now try these. Write down the equation for the graph shown. So the first thing you need to ask yourself, what kind of shape is that? Is that a sine or is that cosine?
Well,
yeah. So that'd be the first thing I ask myself. The second question I ask myself, cosine normally start at 1. but this one, instead of starting at 1, it's starting at 2. So that means we went from 1 to 2. It's grown up by +1, right? Because normally we start at 1, different from the sign. So you need to know the basic cosine. So I know here I've got some sort of a cos signal. I don't know how many period yet, but we've added +1 to it. Maybe it's not the best place to write it because that's where the answer comes. So it's a cos of some sort +1. How many period have I got? 1, 2. So that's a cos 2x. And what's the amplitude? The amplitude for the cos signal is just from there to
1.
there, and it's just 1. So 1 cos 2x plus 1.
So it's important that you remember whatever graph you're given, the way you want to start with that.
Yeah.
The initial.
What's
Yeah.
added on? That's confusing me.
Once you do a few, you'll
Yeah.
find out it gets easier. So let's see what they give us. So this one is cos 2x that's been shifted by 1. Some other people see it better. If they get given that, they take the paper and they draw in the middle and they rearrange it and they say, oh, I can see this is cos because I've moved that up. And then they take it away and then they notice straight away it's gone up by 1. Okay, for the amplitude, it does help. Another one, okay, so this time I've got a cos again. So if I was to half it, it would go along here. Yeah. So I usually half it to give me an idea of the amplitude, right? Because the amplitude is important to get. So the amplitude to me, this is -2. It's a cos of some sort. So how many have I got within 360? 2.
Yeah.
2x. So if I was to start at -2, I would be here. So I've dropped from -2 to -3. I've dropped by -1. And that would be -1. -2 cos 2x -1. Yeah, so that's probably the difficult one when you come to doing cos is where should it normally be with this amplitude? It would be from -2 to +2, and it's been dropped by 1. So maybe it's safer to start with the amplitude, find out where it is and where it should have been. Or you can say, you see that center position is dropped by 1. So you could use that as well if you wanted to. Yeah.
Yep.
Let's try another one. Oh, these are the two that we've just done. And I've put another link here if you want to see some demo. You can go and have a look. So third homework. Lecky 23D. Page 262 and 263. Question 1 and question 3. So very similar to what we've just done. So that might be a lot of information at one go. So that's why you probably need to take your time. Remember, these would be done in school with 3 or 4 periods. And I would always come back. This is what we did yesterday, guys, etc. So just to build it. You've seen it all at once. You might remember it all at once tomorrow, but if you don't practice it, you'll forget about it very quickly.
Have you got like past paper questions at the end of this slide? Just see how last week it was,
Yeah,
there was 60
yeah.
questions.
Yeah, there will be some past paper. So 23D is to sketch in the graph 0 to 360. So let's see, we're going to pick, let's pick one. So you decide which one you want us to have a go at.
F.
F, yeah. So let's try F. How would we do F? I'm going to pick a different color. Pen color, black. So this is how I would do this. I'm given 5, so I know my 5 is going to be my amplitude, but I've gone up by 2. Okay, so that's one thing. The other thing is I know that it's positive, and I'm only going to represent half of it. Okay, so there's more than one way of doing it. I can try and just do 5 cos half x before adding the 2. So technically this would have been better if I had gone right up to 7. Yeah, so let me see. Yeah, so that should have gone right up to 7 in order to go from 5 to 2 plus 2. Because I was only looking at this thinking 6 should be enough, but technically I should have had a better, yeah. So what I'll do is with Desmos, I'll reprint this and make sure that this would go down to 7. So it would have been better if I had -7. Okay, so instead of being at 5, which is where it would have started, I would start at 7. And because I'm going to just show half a period, it's going to drop here and go up to 360 at -7. Unfortunately, I can't show my +7, so I'm going to pretend that I've got the proper one. But everything has been dropped, so no, everything has gone up. Yeah, so sorry, instead of -7, I'm up -3 now. Because we went up by 2. Okay, to make it so that we can see it in this one, we're going to change. Let's assume this was -2, right? So that we can plot it in this. So we've dropped by 2. Okay, so that means we would be down to -7. And instead of 5, I would be at 3. So I would start here. This would be the center. And I would pass here at the 180. This is where I would pass by and going back up that way. So technically, 5 cos half of x would just be something like this and going back to there. That's half a period for cos. Remember the normal cos, if I was to draw you cos x, it would go, this is the normal cos x, right? It would go like that at 90, and then it would go to 180 at -1 like that. And then you would go back to 270 here. And it would finish at 360. That's the normal cos x, right? And if I just do half of it, it just looks like this, which is what I've done here. But because we've dropped it by 2 with a 5 amplitude, so the amplitude is here, so that's your 5 plus 5 amplitude, drop by 2. So that's your 5 cos half x minus 2. Remember, I've changed it to fit in this. But normally, if I had +2, instead of the 5, you would get a +7. And instead of the -7, you would get a -3 here. If I had moved it +2. Okay. That's what it would look like. And then you can just say, this is 5 cos half of x take away 2.
But
No.
the start -2 originally. Am I correct in saying that? That's no.
So if I didn't have the -2 here, the -2,
Yeah.
it would have started at 5.
Yeah,
Remember the amplitude being 5 cos would have been there. But because we've dropped 2, start at 3, and it would have end up at -5, but because we've dropped 2, that's why we went -7.
That's right. Yeah, it's that little part at the end now that we've added on or taken away something to the graph. It's
Yeah.
just practice. Practice the head of it.
If at the start, I think if you need to start, it'd be good to always draw, in dotted line, the ones that you know, the cos x and the sin x. Get the habit of drawing sin x, cos x a few times, and the key parameters being your 90, your 180, your 270. And after having done a few, then you probably get a bit better. Okay, so we can try I this time. So I, you can rewrite it. Remember, they put it 3 plus, but you're allowed to do cos 2x plus 3, right? So again, cos x, I'm going to draw cos x. We said it goes from there to there, back to 180 here. So that would be your cos x. That's cos x, right? Going down the way, back to 270 here, finishing at 360. So that would be cos x. Now I'm going to do cos 2x, so I need to put 2 of these within 360. But then instead of being cos 2x, now I'm going to move by 3. So if this is cos x, moving by 3 is going to go up
4.
to that 4 location. But I need to do 2 of these. So that means instead of cutting at 90, I'm going to cut here at 45. Yeah?
Yep.
So I'm going to cut at 45. And at 90, it's going to be half of it. And the other one would be here. And then here. So that would be something in the line of that, coming back down, coming back up, and do a second one the same way. So 45, just using symmetry. Remember, because we're doing cos 2x, the period now is 180. And then there, and then there, and then at 360, I would be here. So you just draw it again, come down, back up. So this is I cos 2x plus 3 or 3 plus cos 2x. Okay.
Yeah.
So again, it's just a bit of practice. There's quite a few to do. I've got quite a few graphs. So this one, look, I've gone down to -8. Oh, so -8 would have been that 4 and 3, so that would have been 7. So you've asked me to do the first one on the graph that I hadn't put the correct. So the next exercise is for you this time to write down the equation of the following graphs. Okay. So let's pick. You can pick whichever you want. So let's pick. So I've got A, B, C, D, E, F. So you want to pick
E.
Oops. E, A, B, C, D. This one. Yeah.
F.
Yeah.
E. So we can do E. So the first thing I can see here is I've got a cos signal. Yeah.
Mm-hmm.
It's been dropped because this is where the middle of it would be. So it's been dropped by 2. Yeah?
Yep.
So that's going to be in -2. And it's got an amplitude of 1, 2, 3, 4, 5. So my amplitude is 5 here. So I would write 5 cos. Now, instead of cos x, how many can I fit within 360? So I've got 1 and 2 within 120. 3 times 2.
6.
So it'd be 6 that would fit.
Yeah.
So 5 cos 6x dropped by 2. So that's how you would write this one. Okay, so I usually like to put these dotted line because it helps me to see not only the amplitude, but as well if it's dropped down or gone up. But every, sorry?
Even when the line across is quite helpful as well. That kind of is a
Yeah.
big clue. Drop or increase.
Yeah. Okay.
Yep.
So, and the last one, so hopefully we'll be done by 8:30. So we've looked at changing the amplitude. We've looked at changing the period by putting a different value here. This time, instead of changing the period, we're going to change what we call changing the phase. Okay. So let's see what our signal will look like if we change the phase. So as you can see here, I've got sine x, and I've got another signal that have been shifted on the left. It's the same sine, but shifted by 60 degrees to the left. Okay, so by how much do we have to move the standard sine so it fits onto the other? So we've got to move this by 60 degrees.
Yep.
And because we go to the left, we just rewrite it as sine x plus 60. So if you go to the left,
Why is it x plus 60 if you're going back the way? Should that not be
yeah, so
x?
let's find out why it is. So if I've got here x equal negative 60, so what's negative 60 plus 60?
0.
0. So you to get back to 0, you need to make x negative 60. And the only way you're gonna get back to 0 if you do negative 60 plus 60. And that's why you need to add 60. So if you go to the left, you add 60. If you go to the right, you take away 6. You would take away 60. Let's do a few examples, you will see, right?
Okay.
So it's I know it works the other way around. You think if it's go to the left, yeah. Whereas when you were going up, you were adding. When you were going down, you were taking away. Now, if you go left, you add the phase. And if you go right, you take away to get back to where the 0. You need to think about how do I get back to the 0, basically.
Okay.
In order to get this one up to 0, you need to add 60 to it.
Yep.
If I was on the right, I need to take away 60 to get back to the starting point.
Yeah, okay.
So that's the wee trick.
Okay.
To the left, it's a plus. If it's to the right, yeah. So this one has gone to the right. And in order to get back to there, you would need to take away 45 to bring it back to where it was. So by how much? So because we moved there, to bring it back, we need to take away those 45. And that's why it's now sine x minus 45. Remember, we've not changed the amplitude. So if we had changed the amplitude to 2, you would have just put a 2 here. Okay. And that's what phase is all about. To the right, you take away. So in summary for the phase, moves graphs along the x-axis. If it's positive, so it should have been saying for B positive, so I'll fix that. Moves graph to the left along x, and for B negative, move graph to the right. Okay, so I'll fix that. So phase angle, we've looked at sine. We can do the same with cos. So by how much do we move? So we went to the right this time. So we needed to go,
90%.
yeah, you would need to take away, because we've moved to the right, we would need to take away the 70. Because you
Yeah.
went from 90 to 160 there.
I forgot how you get adding.
So if you go to the right, remember you take away. And if you go to the left, you add. To the right, take away. This time we went to the left. Yeah?
Mm-hmm.
So you can see the normal cos has been moved to the left. That means it's going to be plus. So by how much? It's between 90 and 34.
It's 56.
56.
Yeah, 56 degree, yeah. To the left, plus 56.
Okay.
That's the format. Is there a reason why it's bracketed? Is it just
Sorry, is it,
the
so
reason
what?
why both bracket x plus 80 degrees? It's just, why is it bracketed? It's just
Okay, because this is the whole angle.
okay. All right, okay.
Because
So
remember,
whatever
if we don't bracket, it's a bit like you've got cos x and then you've moved it up by 56.
Yeah.
Whereas it's, yeah, this is you talking about angles only, and the wee degree sign is for x plus 56. Yeah.
That's x, right? Okay.
So again, so summary of work: A, amplitude stretches, compress, negative flips. B, now is the phase. For B positive, you move graph to the left. For B negative, we move the graph to the right. And for your last homework, page 269, exercise 23F. And that means we can be done in 5 minutes.
You start to use cosine, sine, tan, and like use it with angles and stuff. Is that when that? Because that's just me living my memory. Is it you get to use that with like?
So yeah,
Is that?
yeah,
I remember high school stuff.
It's good to be able to see what a graph looks like because the next lessons we're going to solve trig equations.
Yeah.
I'm going to put you, for example, 4 sine x plus 1 equals 0. Solve me this trig equation. Then you're going to have to try and find the points of x that would fulfill this equation. Instead of 4x plus 1 equals 0, now we're going to do 4 sine x plus 1 equals 0. And because you've got an idea what the graph looks like, you'll have a better idea how to solve those.
Sure. Okay.
So it's good to have a good understanding of what the graph looks like because it will help you much more when you do trig equations. And there's always a trig equation that comes during an exam. So for this exercise, we've been asked to sketch the graph of the following. So it's just changing the phase. So it's to the right or to the left. So we can pick one if you want.
What about F?
F. Okay, so F. Problem with F, I need to start by doing the tan itself, okay? So I'm going to do tan because we've not done many tan signal, okay? So I'm going to put tan in dotted line. So the tan goes from 0 and it's got a 180. Yeah, so tan itself would be looking like this. So that would be my tan signal, right? And with tan, instead of 1, that would be a bigger, much bigger number. And it would come back down here. And it would cross here. So that would be my tan, because that would be my period. Okay. And if I'm asked to do it within 360, I still need to do it like that. And then you would come back down again here to come back to touch 360. That would be my tan signal. That's what tan looks like. Now, you've asked me to do tan x plus 30. So we said if it's plus, do we move to the left or do we move to the right?
Opposite, so we move to the right.
Right.
Oh, left.
Left. Remember, positive, we move to the left. So that means every point that I've got here, I need to move them by 30 degrees to the left. So that means I'm going to have to start here. This one being here is going to be here. This one that I've got here is going to go here. This one, I'm going to move it by 30 here, and so on and so forth. So basically, this is my tan moved by 30 degrees to the left. And I'm never going to touch this line here. Okay. And then I'm going to come back down from here, and every single one of them as well been moved to the left by 30. And then this would just go right up to here. And again, shift all this by 30 degrees. This would just go like that. And the same for this one. I'm going to start here and just come down like that. Okay, so we've not done many tan, but that's what it would look like. You just shift everything to the left by 30. If it was tan x minus 90, I would shift that by 90 to the right. So instead of starting here, I would start here. Yeah, by to the right if it was this one.
I think that's just going to have to be remembering it.
Yeah, you need
points if you're going.
Yeah. So you
right,
need to remember first the one that is just the classic tan x, and then what do you do with it? And when you draw this, you use your pencil and you can put it in light pencil and then you can just rub it out at the end. It's just to help you. See, I'm using that so that I know every point that just move them by 30. And that gives me a better way to do it. It's always good to put on the paper first what you know it's that, and then use that to play with it. For example, if I was to do B, so this is F, right? Let's say I'm asked to do B. So I know that my normal cos start at 1, come down to 90. So this is my normal cos, right? So this is what cos looks like. Okay, and then come down to 180 here, and then 270. So that's my normal cos signal. So this is things that you need to be able to draw eyes wide shut. Now, plus 30, I'm not moving to the right, but I'm moving to the left because it's positive. This point got moved 30 degrees to the left. That will be here. This point here, 30 to the left, is going to be here. I can put a few in between if I wanted to, but that would be just the whole thing moved by 30. This point would be moved here. this point would be moved here. So I would just go back down, back up again. And instead of finishing at 360, I would come here 330. And then you would come back down again. To get this wee bit here, would just be here. Because remember, you need to draw it up to 360. So it's just that bit there that we need to draw back again. So you don't need that wee portion. It's just for me to help me.
Yeah, straight for 0.
Okay. So that's how you would do. So we've done B and we've done F. So let's have a look. The other exercise is probably easier because, yeah, so for this one, you've just been asked to figure out if it's gone to the left or to the right and by how many. So you've got a bit of tan. I'm going to let you work on the tan, and then you've got maybe 25 pages of past paper. Yeah?
Look, that's been nice to us, not 60.
Yeah, you'll find out. There's quite a few. So let's try. I don't know, which one do you want to try? We've got A, B, C, D, E, F, G, H. It's up to you. You can try E if you want. E. So let's see the question first. Because remember what I said at the start? I said to you that cos is a bit like sine that's been moved to the left. So technically, you can rewrite a cos as a sine signal. But it's sine x plus 90 because it's gone to the left. So if you've got a pen, your calculator, so it's a bit like we said cos x, it's a bit like sine x plus 90 because we moved to the left. So if I do sine 120, what do I get? 0.58, oh, it's radiant.
0.866.
And cos 30 should be the same.
0.866, yeah.
So you've noticed, and that's why when you are given these kind of question, I can tell you, I can do, if no one tells me what I need to do, I can just say, or I can change that to, it's a cos that has moved to the right, but someone else might say, oh no, it's a sine that's got moved to the left. Can you see what I mean by that? Is I can say this is cos that's got moved to the right, or it could be a sine that's been moved to the left. So that's why the following graphs are of the form y equals sine x plus d. So I'm going to say this is a sine signal that's been moved here to the left by this value, but this value is exactly the same as this value here. Yeah, so 180 minus 160, that's a 20, and it's got moved to the left, and we say plus 20. And because it goes to 1, this is just sine x plus 20. Yeah, and if you want to convince yourself, you can tell that sine signal here, when x is negative 20, sine is 0, which is the case, because sine 0 equals 0. You need to get negative 20 plus 20 to have 0, and that works for us. Okay? Sine x plus 20 is this one. For this one, you could be, again, another sine signal, but it's a minus sine x. Or you can say, no, this is a cos signal. So let's see. Normally, if I'm a cos signal, I would pass, this line would be, so cos would be like that. Yeah, so it's probably easier to use sine, but it's a negative sign. The negative sine x would be here, but it's been moved to the right. So our negative sine x, which is here, has been moved to the right by 20. So moving to the right is just x minus 20. Or we can say that it's a cos signal that has been moved to the left by 70 degree. So you can say this is cos x plus 70. So they wouldn't put this questionnaire during an exam by telling you it could be in the form of sine or in the form of cos. They would ask you, write the following graph in this form, y equals sine x plus d, or write it into the other form, cos x plus d. Okay, so this is me giving you both solution. If they had asked us to write it as a sine, it would be this way. If it's a cos, it would be this way.
Yeah.
Okay, and if x is 20, x is 20, what's cos 90? Cos 90 is 0, so that's why I'm cutting at 0. And if I put 20 here, 20 minus 20 is 0, and you would get a 0 as well. So you can see that if I put 20 or 20 here, I would get the same value. And that's why these two are exactly the same. So if I give this as an exam and someone give me that answer or that answer, it should be both correct. Okay. Because of this, cos x is sine x plus 90. You can rewrite any cos in sine because sine is just the complement of, cosine is the complement of a sine. And two complementary angles make 90. And the best one is if you take 45 degree and you type that in your calculator, cos 45 will be equal to sine 45. You can try that because 45 is a complementary angle of 45.
Yeah.
Yep.
Yep.
And that's why you can write this either way. Okay. So you can try sine 90 plus 45. What do you get? Sine
0.7.
Sine 90 plus 45. And then cos 45 should give you the same answer.
Yep. 0707.
Okay. I think that's us for today. Let me see how many. I'm going to stop